Actual weight, 6 stone 9.
Next person.
Stephen Rouse.
Estimate weight.
5 stone 10 pounds.
Actual weight.
6 stone 3.
It's 20 gallons times 8 to make it into pints, and then times 4.
4 foot 10. Actual height, 4 foot 11.
24 furlongs, plus the other 5 furlongs.
You can convert
29.
watts to horsepower.
20 yards in
2.25 inches. Dividing 756 foot-pounds.
When they're live and stiff and fresh, you can't get as many in a crown as when they're...
Drill that .468 hole with 7/16 of an inch drill. Chuck it, turn a 16th off of each end. Finish by a rough turning is 525. 25 thou over half inch. 50 to 70 thou.
Industry is going metric. Why? Well, for 20 centuries, our imperial weights and measures have been proliferating. Ever since those Romans came, we have been adding new values to traditional ones. At present, much of our industry and commerce is based on this jumble of imperial units. Our many special ways of measuring are a frequent source of confusion in Britain and abroad. We cannot work in this muddle any longer, when most of the rest of the world has already adopted the metric system. We've been the odd man out, and we risk losing out on trade. So, industry is going metric, and the British businessman can emerge from behind the crumbling barrier of imperial weights and measures better equipped to break into new metric markets. Metric man is our biggest potential customer. His life is measured by metric standards. He buys all his daily needs in metric quantities and sizes. Metric rules govern his coming and his going. Ah, well, if this crunch comes, British industry can deliver the goods. Our pharmaceuticals have already gone metric. We live by trade in a world whose daily ways are metric. Let's tailor our products to the pattern our metric customers demand. Incidentally, most Miss Worlds have already got it taped. They sound great in metric, 90, 60, 90. Or 900, 600, 900 if you're an engineer thinking in millimeters. Thinking and working in metric gives our engineers, indeed everyone in industry, the opportunity to bring in new ideas. To advise and guide them, there are the Metrication Board, Chairman Lord Ritchie Calder, the British Standards Institution, Bob Fielding, and the Confederation of British Industries, represented by Eric Felgate.
In 1965, the CBI's predecessor, the FPI, went to the government and suggested that the country really could not afford to delay going metric any longer. I don't say that every firm wanted the metric change, but a majority certainly did.
When the British industry decided or convinced itself that it should go metric, as part of this world historical process, the government gave it all the backing it wanted. And its part of this process was to set up the Metrication Board.
Now, the CBI works closely with the Metrication Board, with members of ours serving on its steering committees, and making sure that the practical needs of business, especially of small business, are understood.
We have no power to compel anybody to go metric. We can persuade, we can coordinate, I say we can help them to see how they're working in conjunction with other people. And indeed we can communicate and keep them informed, provide them with early warning systems and provide them with publicity to create the climate of the change. But this is a job of persuasion.
If British industry is to keep pace with the rest of the world, let alone take the lead, we shall have to go metric ourselves sooner or later. And the CBI thinks it makes sense to go metric now.
I regard myself as a hot gospeler. I am not in charge of the metric system. I am in charge of the metrication board, the process of going metric. The holy writ, if you like, of standards, and units and so forth, are elsewhere. Standards, for example, with the British Standard Institution and with Mr. Fielden here.
1,400 British standards are already in metric units, and we are adding to them at the rate of over 500 a year. We're using the international system of metric units, known for short as SI. Many of us are familiar from our school days with the centimeter gram second, or CGS system of units. For industry, larger units were needed. So the MKS, or meter kilogram second system, developed. Now we have a metric system which has been accepted throughout the world. There are 6 base units: the meter for length, the kilogram for mass, the second for time, the ampere for electric current, the Kelvin for temperature, the candela for luminous intensity. SI is a coherent and logical system. So from these 6 base units, we can derive all the others. For example, 1 meter by 1 meter gives 1 square meter, the unit of area. For velocity, it is the meter per second. There are other more technical units, including the Newton for force, named after the great Isaac, which are becoming rapidly accepted in science and industry. To prevent numbers becoming unreasonably large or small, we use prefixes. For example, kilo means 1,000 times bigger, and milli means 1,000 times smaller. That, very simply, is the essence of the international system of units. It's already been accepted by all the industrial countries except those in North America.
Now, it's true, isn't it, that here in Britain we are taking a lead amongst these industrial countries in making a jump from the, not only from the Imperial, but over a lot of the difficulties of the conventional metric system.
And that is quite true. We're leapfrogging the continent.
You know, what I find about so striking about the SI system is that it's so simple to use because it's coherent.
You can forget all those horrible conversion factors we were all brought up on. You know, 746 watts equal 1 horsepower, 33,000 foot-pounds per minute ditto. All those go. In SI, you can start with the fuel into a power station and come out with the ultimate kilowatt without needing a single conversion factor down the line. Similarly, the ratings of domestic heating equipment will all be in kilowatts, so that you can compare one form with another.
So here we've got a complete universal numerical language. In fact, these engineers and the scientists and the people on the shop floor and the salesmen are now talking the same language all over the world.
Like the Anglo-French team building the Jaguar aircraft.
The load at the moment is 2,050 kilograms. With this new tank, it's going to bring us up another 200 kilograms. 200 kilograms. But we're going to have a bit of problem with this switch.
This is a switch that we agreed.
The use of metric units speeds up communication between the various technologies. Mechanicals can now talk to electricals, to their chemical friends, those who are doing fuel flows, the same units, the same language, so that all of them now will be able to abandon using their slide rules to talk to one another.
The right length is 1 meter for the probe and 3 meters more to go to the switch.
Yeah.
There is 4 meters.
The Anglo-French Jaguar is the first complete aeroplane built in Britain from metric drawings, and as Mr. Campbell tells us, the British Aircraft Corporation has been working in metric for some time.
Well, here at BAC, we have found that in this changeover to the metric system, the problems which we anticipated would give us a great deal of trouble have turned out to be very much simpler than we thought. On the shop floor, the use of metric system enables the two national teams to talk to one another in the same dimensional language, and this makes for a great deal of simplification.
Offload wheel nuts to 20.5 Newton meters. So you set that up.
Although there are distinct advantages in the use of SI units on the shop floor, the area in which the greatest advantage occurs is in the design and technical area.
Our problem on design was the question of stopping the draftsman from thinking in inches. This we did by reading the Riot Act to some extent and introducing them to the fact that using metric dimensions, they should be working reasonably in whole numbers. There isn't any question, but the use of SI does speed up the calculation. We have got rid of a lot of extraneous conversion factors and are working strictly in powers of 10. We have here a coherent system. Not unnaturally, when we started to change over to metrication, we had certain worries. One of these was the dislocation that might occur both in the design side and work side through a fall-off in productivity of the operators. In fact, this is something which we never noticed. We couldn't point to anything where metrication had caused any disruption. One of the problems which does arise in manufacture is the making of tools and jigs for a metric aircraft. In our tool room, we had a jig borer calibrated in inch units. We provided the operator with a little calculator so that he could convert the millimeter dimensions on his drawings into inch units. We have since replaced this by our metric jig borer, where we have to provide an inch part. He uses his calculator to reverse the procedure. We found that the amount of retraining which was necessary was much less than we anticipated. We have, in fact, I think, all through this been inclined to underrate the intelligence of our work people. They have picked this up very much quicker than we expected, so that the amount of retraining we had to do was quite small.
This is a wonderful opportunity, a golden opportunity for a whole spring cleaning operation, clearing out the lumber room of old habits, of the traditional ways of doing things, and making enormous economies. Now, the big boys have found this out in a very big way.
Not only the big boys. Metrication isn't just for the large companies. After all, a great many small companies are very much bound up with them as suppliers. Other small companies are specialists in their own right, in services or products. They too are going to benefit. And quite outside these categories, people are going to benefit from the general improvement in technological standards, which is the whole aim and object of the metric change.
Let me give an example from the building industry. In the old Imperial range of standard windows, there were no fewer than 1,600 different sizes. In the metric range, going from the same big to the same small, we're doing it in under 200.
At Durox Building Units, Mr. Clarkson describes his company's experience of going metric.
The three main reasons we decided to go metric. Firstly, to reduce the range of standard components from 1,700 down to 700. We also felt it was a good opportunity to obtain modular coordination within our products. Also, it was an aid to exporting to other countries. Everyday concrete is manufactured from three basic raw materials: lime, sand, and cement. The material is mixed into large molds and is then cut into various components by means of wires, similarly to cheese. In December 1968, we decided to seize this opportunity and manufacture metric sizes. To do this, we closed our factory down for 3 weeks, changed all our molds and cutting systems, etc. Although we realized that we have to phase out our Imperial size units over 18 months to 2 years. The difficulties are due solely to labor not being conversant with metric sizes. But we have overcome these problems. Our labor is now thinking in metric terms and not thinking in terms of imperial measurements.
It's simple to demonstrate that, compared with traditional size building materials, metric blocks used in a modular system with metric components save a great deal of time and money.
Going metric means to the construction industry that all components will be produced to common metric preferences. A full metric modular system offers the customer faster and more accurate building with less wastage, in fact, higher productivity for relatively lower costs. There's no secret ingredient here, only dimensional coordination and standardization of components, yet standard metric units still leave room for personal preference.
Rationalization isn't the whole story. There's been another benefit out of the use of the international system of units, and this has come in the shape of a bonus known as the concept of preferred numbers. And this is a general idea which can run through the whole scheme of things, beginning with raw material sizes, bolts and nuts, electric motors, hydraulic cylinders, and so on. And the sizes go up, instead of in the arbitrary steps we've been used to, in internationally agreed ratios. And this will lead to a great variety reduction throughout the piece.
The effects of rationalization due to metrication must undoubtedly mean that in the long term we're going to use a smaller number of different components, but in greater volumes of each component. This is the big advantage that is obvious.
This is the opinion of Mr. Elms of Guest, Keene and Nettlefold.
I personally welcome the new standards that have been produced by the BSI, and I'm quite certain that this goes for industry as a whole, because we all realize that without the standards, then we would have nothing but chaos. I think the main benefits of metrication can be summed up quite concisely. In the first case, it is an opportunity to reappraise the engineering standards that we have taken from our forefathers and decide which we really need, with the objective of reducing the number of different diameters and lengths that we use in our engineering constructions. Particularly, we must encourage the user to select preferred diameters and preferred lengths. And secondly, it is a means of coming in line with the majority of the world from an engineering standards point of view. Those are the two big ones.
Metrication gives us the opportunity to sort everything out. We simply must not waste this chance. So, how do we set about it? How long will it take? What will it cost? And what do we hope to get out of it? Now, I can tell you from our experience in the board, that in point of fact, the upheaval in industry is nothing like as serious as one would have anticipated. The difficulty isn't so much learning metric, it's unlearning the imperial system.
But unlearning the old ways isn't so difficult, even though Joe has always thought of pints, or inches, or pounds of one sort or another. When Joe's factory goes metric, Joe's mind can change gear rapidly, with a little help. To start with, he should beware the temptation to convert everything into the old units. He'll learn the new measurements quickly enough, but must guard against slipping back to more familiar values. Learning to think metric isn't the uphill struggle that people imagine. The main thing is, just forget the old terms. Joe will find metric units provide a simpler, more coherent path than the tangled web of imperial calculations and conversion factors. And given a sensible approach to training, the new path is easy to learn.
Metrication is like learning a new language. Translation is no substitute for thinking in the language. Conversion is only a short-term solution and will inevitably lead to errors, particularly if dual working is not kept to the absolute minimum. Everyone must be trained to think metric as quickly as possible. But it's most important to evaluate the level of people's needs so you don't confuse them. Metric education must be universal. That is to say, academic training should be coordinated with practical working. Indoctrination should, if possible, begin at least a year before the changeover, and metric training itself should begin immediately before metric working commences. People must learn to think and work instinctively in metric units. What a meter looks like, a kilogram, a litre. Now, how can this be achieved? Well, before discussing how, people should be told why we're going metric. And having solved the idea, you can embark upon a training program of lectures and practical demonstrations. If you approach it in the right way, training people to think metric is not a difficult problem.
Well, I've had a little practical experience on the shop floor. In my old company, when we built equipment for export to metric countries, it had to be made in metric dimensions. And we found that our men quite soon got used to and got to like the metric measurements very much. At the national level, there is a big problem of planning, however.
Yes, I think there's an awful lot to be said, you know, for having one single officer who is both responsible for the outline plan for the company, and it also is the focal point for all the thousands of questions that are going to arise. He may not be able to answer the questions himself, but he ought to be able to know where to go for the answer. Otherwise, decisions will be uncoordinated and planning will not go smoothly.
Firms must obviously plan their own timetable to suit local conditions. One can expect a longish period of preparation for going metric, followed by a steeply rising curve of activity. But don't adopt an after-you, Claude, attitude, waiting until you can get metric stocks. Other firms are not waiting, because stocks of metric raw material are already available, according to Mr. Macready.
We felt we had a duty to the engineering industry to place in a very large stock of metric steel to the qualities and sizes which we felt they would require. And so we acquired additional warehouse space of some 27,000 square feet, or perhaps I should put that into 2,500 square meters to be more exact. We have already installed a computer to handle our stock records, invoicing procedures, and for giving us accurate information on the demand and the sales of metric specifications. Today, when any company makes an inquiry, what are we doing about the supply of metric steel, we have a quite simple answer. We send through to them with a covering letter details of the stocks already in existence.
And Mr. Lowe assures us that supplies of metric fasteners are available.
We were faced with a decision whether to sit on the fence and wait for a demand for metric fasteners to build up and then fulfill it, or to lay down a stock range, thereby hoping to create a demand. Many people said that they could not even plan for metric change unless they were assured of the availability of metric fasteners, and therefore we had to make this decision and to put in a wide range of metric fasteners, and these have been found to fulfill the majority of requirements during the transition period. Now, we are, of course, constantly reviewing and adding to our stock ranges. Now, the important point is for the manufacturer or the designer, when he's making a metric design, to consult us in advance and present us with a detailed breakdown of his requirements. If these breakdowns are sent to us, they can be collectively examined and our stock ranges can be adjusted accordingly. GKN first started to look at putting in a stock range of metric fasteners when the British Standards Institution inquired of the supplying industries their readiness to supply metric components and also when they were prepared to do so. We have, of course, to supply what the customer wants and when he wants it. And we therefore intend to stock and manufacture these Imperial sizes for as long as he does want them in volume quantities. When these quantities become uneconomic, they will carry a price premium and will slowly be phased out. Furthermore, metric components will be very much easier to obtain because they will become a first choice preferred thread, and deliveries and availability of them will be very much easier and better than the obsolete Imperial components.
The conversion or replacement of machine tools should not delay the change to metric, according to Mr. Harrison of Alfred Herbert Limited.
There may be people who are worried about the problems of their machine tools and going metric. I can assure them that the British machine tool industry is anxious to help with this problem and has products capable of assisting this change readily. I believe that the change to metrication will take as long as the average cycle of replacement of products will take, so that by changing over on new designs, the phasing out of obsolescent tooling and gauging can be done more readily because the new designs will involve the phasing in of new gauging and tooling. Where the policy is that the introduction of metric will be phased over some time, the workshops will be producing sometimes in metric and sometimes in imperial. There is no need for the purchase of a lot of new machine tools. Most manufacturers can supply equipment to provide the machine with dual measuring devices. One of the most common is that micrometer dials are duplicated on a machine, and the metric one is driven at a slightly different rate from the imperial one by internal epicyclic gearing. One of the more sophisticated measuring devices is the digital readout. This measures dimensions in absolute terms, and these can be expressed in either metric or imperial standards, the choice being determined by the location of a switch. Numerically controlled machine tools can accommodate conversion to metric relatively easily. Usually the method of doing this is to put the conversion into the tape so that the machine, whether it is built to imperial or metric measurements, produces to the metric requirements. As far as gauges are concerned, there is a different problem here because generally gauges are made so that they do not wear, and consequently they seldom have an adjustable characteristic, and gauges really have got to be replaced by gauges made to metric measurements. Training will be needed, particularly people with the problems of different tolerances. Most British engineers are familiar with the thou and the quarter thou and so on, and many of them do not even know the terms used with metric tolerances. This is a matter for education and training. When companies have changed over completely to metric, they will have no problem with machine tools because the British machine tool industry has been exporting machines to metric-using countries for many years and is quite familiar with the requirements for those circumstances.
Brook Motors is one of the firms which already has a stockpile of metric experience, according to Mr. Hall and Mr. Bentley.
Brook Motors started to go metric in 1961 because we were anticipating the coming of the common market, and it was obvious that to get business in that market we should have to make to metric dimensions.
Then, with the advent of the British standard change to metric, we decided to close down the inch lines and now produce something like 85% of our motors for Europe and the UK in the metric frame sizes.
The first steps towards metrication covered those aspects of the motor which affect the customer. The shaft center rise height, the shaft diameter, and of course the bolt holes for fixing the motor down to its base. Going metric has reduced the size of the motor, and it's a few pounds lighter, or perhaps I should say kilos.
When we went metric, the only real problem we had was a flange-mounted motor, and in this case it did unfortunately mean a redesign throughout the range. This change did cause interface problems with our customers, which had to be solved.
By planning ahead and cooperating with our customers, we were able to reduce these problems considerably. Of course, when Britain goes fully metric, designers will be incorporating metric motors into machines designed to metric standards, and the problem will disappear completely.
In Europe, we have strong competition, and if we hadn't gone metric, it would have become practically impossible to sell any motors to our friends and neighbors across the water.
When we've made this change, we shall be using the same units of measurement as nearly 90% of the world's population, speaking the same language of measurement as they do. And we shall get this tremendous bonus in simplifying, rationalizing and economizing in all we do in industry, in commerce, and in the home as well.
There's only one good reason for going metric, and that's because it's good business. Good business for the company and good business for the country.
This is a revolution, a painless revolution which should have happened many, many years ago. But now we are setting the pace for the rest of the world as we did in the first industrial revolution, and the benefits are going to be enormous.